Good afternoon, and welcome to Statistics and Data Corporation's Innovation Theater webinar on infrastructure and team architecture, enabling efficient capabilities in artificial intelligence and machine learning. My name is Dale Usner, and I am the CSO and Senior Vice President of Strategic Scientific Consulting at SDC. A few years ago, we initiated the establishment of our Data Insights and Automation Department to reduce human time on lower-level tasks, thereby allowing employees to focus on higher-level tasks, to improve repeatability of processes, to support more efficient human data interaction, informing better insights through intelligent reporting and improved interfaces, and finally, to mitigate risks through the use of standard key performance indicator metrics and clinical data review. I am excited to introduce our speakers for today, who will be presenting our learnings on infrastructure and team architecture enabling efficient capabilities. Julian Phillips, Director of Data Insights and Automation, with over 10 years of data science and software development experience in the financial and medical industries, Julian specializes in translating business needs into software applications and data science, and has spearheaded the building of SDC's Data Insights and Automation Department. Anthony Hall, Data Engineer, with 5 years of data engineering and analytics experience across a variety of industries. Anthony specializes in dimensional modeling, database design, and data integration and security, and has architected and implemented the building of SDC's data warehouse. And now I'm going to hand it over to Julian.
Thank you, Dale. Today, we would like to talk to you about our journey that was started 18 months ago, the progress we have made, the missteps that have occurred, and the outcomes that we are excited about. Artificial intelligence, of which machine learning is a component, has really transformed industries over the past decade, and that transformation is starting to be seen in the world of CROs. However, developing models without a solid foundation is a recipe for frustration and wasted resources. Our Chief Scientific Officer, Dale Usner, recorded a podcast for this conference called Data Science and Automation, Driving Research Science Forward, in which he describes the company's decision to create a department that was dedicated to data science and artificial intelligence. This is a continuation of that podcast, starting at the point in which I was hired to create and lead the department. As Dale mentioned, I have a background in data science and software development. However, I had no background in CROs. If I am being honest, I was not even aware of the existence of this industry. So at the same time that artificial intelligence was going to be introduced to CROs, CROs were going to be introduced to me. The leveraging of artificial intelligence and machine learning models can lead to impressive results. However, a solid foundation needs to be laid in order to ensure future success. If there is nothing else that you retain from this presentation, I hope it is that statement. At the same time the foundation is being laid, there are parallel activities that can be done that will both enhance future data capabilities and automate various pieces of the CRO study workflow. So where did we begin in the laying of that foundation? The first step for the department head is to take stock of the landscape and to determine current needs and capabilities of the company in 4 different areas: processes, infrastructure, personnel, and data. The state of these 4 areas will drive early, impactful decisions. There is a common theme that runs across researching all 4 of these areas, and that is talk to existing employees. They are the best resources to understand where the company currently is. In fact, I believe it is advantageous to talk to both department heads and individual contributors. They will end up having different views of the same portion of the company, and those will be illuminating. The first 2 areas we will discuss are processes and infrastructure. First, processes. Some questions that could facilitate learnings include, what processes are taking the most time? What processes' accuracy could improve? What processes are considered tedious and unappealing by employees? Additionally, if any metrics exist within the company detailing rework, they can be used to determine which processes could use improvement. Infrastructure. Oftentimes, there is a piece of code or a vital spreadsheet that exists somewhere within the company that only a few people are aware of. And even then, they may not know a whole lot about it or its history. However, finding them is important, as otherwise you might duplicate efforts, or even worse, provide conflicting information. Some questions here include, what software as a service providers is the company currently using? Is there any current code base currently running automated tasks or offering support? In fact, this last question was not one that I initially asked during my early conversations with the departments. There was an entire code base providing support to the operations team and running on a regular basis that was unknown to us. Luckily for us, that does not impede us, and in fact, it turned out to be beneficial as there were parts we ended up reusing, but it would have been a lot better if we knew about it earlier. The next step is personnel. As I mentioned earlier, the entire department was unfamiliar with CROs. I do believe that having someone with the data or software tools, in addition to CRO knowledge right from the beginning, would have been helpful. So in order to find those people, this is the next area we will discuss. So what are the talents of the employees currently in the company? You need to understand what the current skill sets within the company are. Of particular interest are programming languages, application development, database usage, both as an administrator or end user, Linux experience, and data science. Even if those resources are in areas that cannot afford to lose them, perhaps they can be shared in the future. At a minimum, they can help translate between the two worlds. Lastly, understanding what typical data looks like in the company will be important for a department who relies upon it and who will be depended on to provide the capacity for data-driven decision-making in the future. Discovering where the data is stored, what formats the data is in, and what the sources of truth for the company are all needed to design future solutions. What is a source of truth? A source of truth is data upon which all stakeholders agree is the real, trusted number. Processes should obtain data from this same source of truth. For example, for CRO studies, one source of truth is data within an EDC. Any clinical data for that study within the EDC is assumed to be true. This is one of many sources of truth within most companies. After understanding the company's current state and processes, infrastructure, personnel, and data, decisions need to be made which will set the department's direction for the future. The absolute first decision that needs to be made is whether to buy or build. That is, building the capabilities in-house or partnering with a third party. There are pros and cons with each approach. For us, the decision was to build it all in-house for a couple of reasons. First, while partnering with a third party would yield quicker results, which is by far the biggest reason to buy, it is also considerably more expensive. The annual cost for 10 studies at many of these vendors is the same as our entire annual budget inclusive of all salaries. In addition to cost, other advantages included the ability to customize our tools for our needs. For instance, our most frequently used EDC is not supported by many of these vendors. While they could build that connection, it would certainly drive the costs up higher. Finally, by choosing one of these vendors and choosing to buy, the other capabilities that this department can unlock, such as standardization and automation, are not gained. After we decided to build this in-house, the next decision was the personnel mix. There are 3 primary job types within this department: data engineers, software developers, and data scientists. The mix of personnel, along with the experience desired for each role, can vary quite a bit depending on what was learned in discovery. For instance, if there is an existing data warehouse, or if data is more structured than average, then data scientists can be hired earlier. If there are many different systems that are not connected, but it would be beneficial to do so, then more software developers would be helpful. If there are not as many sources of data, or if they are more mature with comprehensive documentation, then a less experienced data engineer, or possibly somebody in a business intelligence hybrid role, could be a possibility. Cloud providers offer the ability to quickly scale up and scale down resources as needed without the need for dedicated IT staff. Nearly all data engineers and software developers are already familiar with working with them. Choosing not to use a cloud provider would have slowed us down to an extreme degree, probably with minimal cost savings. Finally, which programming languages will be used? Python is the most common language that data scientists know, and it is great for most other general programming activities. If there is a strong history of other languages within a company, consider those. If there's a strong need for web applications, a dedicated front-end language such as JavaScript or PHP might be appropriate. Minimizing the number of languages is essential to having the department collaborate and back each other up. Even when decisions are made, they sometimes turn out to not be optimal. Do not be afraid to take a step back to be on the correct path going forward. One lesson we learned was on the infrastructure side. We have many different programs that need to share resources. Choosing how to share those resources was the decision we made very early on that had to be reversed. Originally, we chose a path because there was in-house expertise with that method. However, it became clear within a couple of months that this choice was leading to more debugging and rework than I was comfortable with. So we made the decision to replace it with a different piece of technology in which there was no in-house expertise, but it was quite well documented. While that cost us about a week or two to replace it, since then the amount of debugging and rework has been reduced by 90%, allowing us to get more work done quickly. While deciding on personnel, infrastructure, and programming languages is a big milestone in the creation of this department, what comes next will determine the success or failure of this new venture. Now it is time to integrate the company and start working with the existing departments. Our experience was that few operational employees had experience working with a department focusing on data and automation. Also, as mentioned, our entire new department was new to the world of CROs. So educating both ways was needed to set up the department for success. We found it took about 9 months or so before it started to click in both directions. Adding a new department to any company will lead to a change in dynamics. While the department head should communicate and coordinate early and often with other department heads, this is a vital time for senior leadership to ensure that its integration goes as smoothly as possible. There is a possibility that there will be apprehension towards the new group. It is unsurprising that employees hearing that a task of theirs is being automated can make them nervous. Emphasize that while some tasks are being automated, those tasks are tedious and time-consuming. Removing, or more likely reducing, those tasks leads to more complex and interesting work and happier employees. Because at the end of the day, the primary customer for this department is the company itself. This is worth repeating. The primary customer for this department is the company itself. Now, this does not mean that external customers will not benefit from the work this department is doing. After all, the automation and data models we will be providing will lead to shorter timeframes, higher quality, and increased consistency, something that all customers are interested in. In addition, while the primary customer is indeed the company, applications for external customers will also be developed. However, between laying the foundation of the department and taking care of the needs within the department first, it could be several years before focus can be shifted to external customers and their applications. Another source of confusion is language, and this time I'm not talking programming languages. Unsurprisingly, different industries have different languages, and CROs are no exception. Coming from a technologies background, there were several words that have different meanings depending on the context, and ensuring everyone knows which meaning is being discussed prevents confusion and mistakes. Some words that are different in CROs versus technologies industries include endpoint, query, data management, domain, and phase. One of the first steps that was mentioned in this conversation was the department head learning the CRO workflow through the processes within the company. Now that some opening decisions have been made about the direction of the department, it is a good idea to revisit the study workflow and expand upon it in more detail. One place to always keep in mind is the opportunity for quick projects. The definition of quick varies, and the one that we use internally is any project that should be able to be fully released within a month. There are huge benefits from these types of projects this early in the life of the department for everyone involved. From the perspective of the customer, or in this case, the other department, they can get a better understanding of what can be done, what can't be done, and any other impacts that may not have been obvious at first. Additionally, something that was a pain for them has been resolved or removed in a better way. For the new department, these projects will be completed by new hires early on. The benefits for them include getting a project under their belt, being able to work with people that will be their customers for years, as well as to get a better understanding of exactly what a CRO is all about. While quick projects are a great start, their return will often be smaller. Long-term projects are where the bulk of the benefit from automation will be felt. Review all the pain points that have been discussed and go back to the department heads and get some information about how many person hours per month each of those take, along with estimated time savings and quality improvements that would be apparent if this project was completed. Those are the ones that I would discuss with senior leadership to prioritize. Another project philosophy that I have, and I believe is beneficial, include release small, frequent releases and updates to applications rather than infrequent, large ones. The benefit here is that relief comes quickly, even if it's small at first, and pitfalls might be avoided as small releases could uncover new information that ends up changing the direction of the application. Next, I would like to hand it off to Anthony Hall, our data engineer, who will discuss the development of our data warehouse solution. Anthony?
Thank you, Julian. It has been my pleasure at SDC to lead the design and development efforts for our enterprise data warehouse. I'm excited for the opportunity today to present to you some lessons learned and insights into how we went about it. Hopefully, they will be valuable to you on your journey toward developing artificial intelligence and machine learning capabilities at your organization. The key elements and lessons learned we identified in designing and developing our data warehouse fall into three categories. First, the design considerations unique to our business as a CRO. Second, the considerations common to data warehousing, or what I like to call the data warehouse hierarchy of needs. Lastly, but extremely important in the current world we live in, access security and data privacy. There are three areas to consider when designing a data warehouse for CROs. They include segregating client data, handling blinded and unblinded data, and understanding data ownership and provenance. As a CRO, we work with many different sponsors. Each sponsor can have multiple studies, all of which can have various design, reporting, data, and security needs. As a result, being able to keep client data segregated will help to ensure data integrity and privacy is upheld. However, this can present challenges to the standardization process, both in data and reporting. Based on this consideration, two routes seemed plausible for us at the time. One is microservices route, where we could treat each study or process independently and handle the individual exceptions as they come. Or we could standardize the data first and do the heavy lifting up front. We chose the latter because we felt that although it would be a longer ramp-up time in the beginning, it would save on maintenance and rework in the long run. At SDC, we have been able to leverage technologies that make our data warehouse more dynamic and adaptable. This allows us to make changes in one place and apply them to all our studies with fine-tuned adjustments when needed. The first portion of our data warehouse design and build focused on EDC patient data. This data can often have masking requirements for blinded and unblinded data. Since the masking typically occurs inside the EDC and is strictly controlled, extracting the data from EDCs increases the risk of unmasking. When first extracting data, we recommend working with blinded data to avoid this risk. Much of the design and development of the warehouse can be done without handling unblinded data. This enabled us to focus on the quick wins that could be achieved with blinded data, then move on to unblinded data. Many modern data warehouse technologies include masking capabilities that can be leveraged as well. Lastly, as a CRO, we are stewards of our clients' data and not the owners. As a result, we need to know when, where, and how our client data is used and stored. We accomplish this through tagging and providing tracking IDs to the data elements as they move through our data pipelines and storage locations. This allows us to know where our customers' data is at all times and how it is used. It also helps to facilitate data privacy regulations like GDPR. Now that we've considered unique requirements to CROs, let's focus on what is common across industries. We have found a model that helped us to understand how to prioritize our efforts. This model is the data warehouse hierarchy of needs. This is derived from Maslow's hierarchy of needs for any psychology buffs out there. Just like food, water, and shelter are our basic needs as humans, data projects, such as a data warehouse, have basic needs. These needs are first, collecting and understanding what data is available. Second, how to move, store, and transform that data. Then we can standardize and augment our data so it is valuable to us. Lastly, we can actualize all this work and effort by applying analytics, machine learning, and artificial intelligence. I really like this mental model for data projects because it puts the focus in the right place, on the foundation. Often, artificial intelligence, machine learning, and data visualization are the flashy thing people want and ask for. What they don't realize is that if the foundational elements are not in place, the chance of success for those projects will greatly diminish. In this graphic, I have also added sections for data science and data engineering. As Julian mentioned, when building out our team, we knew we needed a mix of skill sets. If you are hoping for a single person to do this, you might be disappointed. A data scientist that is also a skilled data engineer is what we like to call a unicorn. Do they exist? Perhaps, but finding one will be very difficult. Therefore, when starting out, it is important to ensure the team has solid data engineering skills available to build the foundation. This foundation is built upon understanding the data and the business processes. The best way to do this is by conducting discovery interviews with subject matter experts across the organization. When conducting these interviews, the goal is to understand how the business uses the data, what data elements are the most important, and where or how that data is accessed. The subject matter experts will be the most important resource in understanding the key dimensions and facts that will go into the data warehouse model. Without an accurate understanding of the business, it will be difficult to develop. When conducting these interviews, key data attributes will be brought up again and again. In our case, these were sites, subjects, forms, questions, which we labeled as dimensions. Then we identified key measures and metrics that are analyzed in the clinical trial process, and these are called facts. When conducting these interviews, we found a few high-impact questions to focus the interview and yield the most value. A few of my favorites are listed here. For example, how do you identify problems or exceptions or know you're heading for trouble? This question will often point you to important data they monitor on a regular basis to make sure their team and projects are not at risk. Next is a more on the positive side. How do you know you are doing well? This helps you to identify success metrics that can be used in a positive way to inspire and motivate. These data elements are important as well, because when doing data projects, we want to look for the highest impact and value in the process. Once we understand what data is used and where it resides, we can begin to prepare it. This is often called ETL, which stands for extract, transform, and load. These are the steps we go through to get our data into the data warehouse. ETL has been the popular paradigm for decades. However, with the advancement of data warehouse technology and the growing amount of unstructured data, a new paradigm has emerged, ELT. Now, before you think we are just changing letters around, this is actually a big difference and has significant benefits. First, this allows for better management of unstructured data, which is common in modern EDCs and software. Next, it allows for both raw and transformed data to exist in the same location, to be queried and analyzed. Having access to the raw and transformed data helps data scientists and data engineers see how data moves through the pipeline and allows them to iterate quickly when developing reports and analyses. After the data has been collected and loaded into the data warehouse, it can then be transformed. This is where the understanding of dimensions and facts discussed in the discovery interviews with the subject matter experts will come into play. A dimensional model will start to emerge and be the end result of the data transformations. As an example, the CRF record responses become the center fact table, with the dimensions acting as points on a star, as you can see in this image. These dimensions are subjects, sites, questions, and forms. As I mentioned previously, this transformation process should be as adaptable as possible. Requirements will come up later when looking at the data that didn't come up during the discovery interviews. Being able to adjust your transformations quickly will be critical to the project's success. For example, dates can often be problematic. We were extracting data for medical histories and noticed the day and month are recorded frequently as unknown. However, in order to display dates in dashboards and visualization software, the full date is needed when users want to drill down. Deciding what those unknowns should be imputed to represent is a business decision and should be consulted with a wider audience, documented, and displayed on reports to allow for accurate interpretation. If discrepancies such as these are not addressed, it can lead to wrongful interpretation of results. Now, after all that effort of developing the data pipelines and designing a model, we can start to augment our data. Fortunately, we are in an industry where much of the labeling and standard setting has been done for us. As a result, we used CDISC and CDASH data standards as our guides to label and aggregate our data. Standards such as SDTM and ATOM are leveraged to facilitate the creation of these data sets for the required regulatory bodies and analyses. We found, however, that at times the EDCs we work with may or may not facilitate this process for us. Where possible, leverage these capabilities, but understand that it may not be complete and still require post-processing. Julian will cover a little more detail into our efforts here with aggregating and labeling our data. Finally, after this foundation has been set, the risk all too common in AI and machine learning projects of bad data in and bad data out has been mitigated. I cannot stress enough how important it is to make sure that the data quality and integrity is high before you start to develop your artificial intelligence and machine learning models, which is why this was our focus in the beginning. This results in high quality models with greater precision in your delivery. Throughout the design and development process, access security and data privacy should be top of mind. Our approach was privacy by design and secure by default. This started with how we would secure our data. The two key concepts I would like to address are authentication and authorization. I like to think of this as walking into a secure building. Authentication allows you to enter the building, and authorization is what you can do or see once you're in there. If you can authenticate or walk into the building, great. But if you don't have authorization to enter any of the rooms inside, you're just staring at the doors. One thing we learned was that people didn't want another username and password to manage. Additionally, security goes down the more usernames and passwords one has to manage, because individuals start using the same password over and over and over. To avoid this risk, we leveraged single sign-on and multi-factor authentication. When selecting a data warehouse, these security features were required criteria. Regarding authorization, access to data can get complex very quickly. Team members, internally and externally, are assigned to multiple projects, and teams can change. This occurs often and can be a headache to manage. The provisioning process can be handled separately or tied to the existing systems from which the data comes from. In our case, the operational systems, such as EDCs, have robust user access control policies and procedures. Instead of creating another provisioning process, we ingest and update regularly the user access definitions from the EDCs. This greatly simplifies our process and keeps security consistent throughout. These design decisions allowed us to centralize the authentication and authorization. Connecting them to pre-existing processes limited the impact to the business while maintaining a safe and secure environment. The data warehouse design and development project provides a solid foundation on which we have launched other high-value initiatives. Julian will cover a few of these that we have been able to unlock and what we have learned from them.
Thank you, Anthony. The deployment of the data warehouse has allowed the department to accelerate our efforts with other projects that assist operations. We will next discuss projects that have been developed in parallel or on top of the data warehouse. First, I would like to talk about our data standardization project, which is also our first data science model. Anthony mentioned this in his pyramid. This is a key model as it unlocks the capabilities of additional models and the ability to use common code bases for reporting and other applications. These will be discussed later. In order to make the data warehouse the most useful across the most studies, standardizing the names of questions and forms is essential. While there are many reasons why these names could differ, standardizing them using C-conventions is suggested. Current and previous studies need to be handled differently than upcoming ones. Renaming variables once the study has been started or completed is not a possibility. For current and previous studies, aggregating and analyzing form and variable information from the EDCs is a starting point to see how to standardize. Look at common names as well as uncommon names. This helps develop the mappings that will be used early on as they find the easiest to standardize. The remainder that are harder to standardize will be processed in a second machine learning model after most domains have already been standardized. This is an example of releasing small updates to projects in a quick fashion rather than waiting for large ones. For upcoming studies, I suggest monitoring the staging environment in an automated fashion, and then check variables and forms against known standards in that staging environment. Alert the study team of any non-standard ones and see if they can be changed before the study goes live. While there are reasons to use variables that are non-standard, they should be as rare as possible, as they will have to be standardized to be of any use later. Some companies have an advantage as they only work with themselves, and thus they have the ability to more strictly enforce standardization versus others who work with various sponsors and EDCs who may have conventions that they want to keep in-house. Finally, let's present some metrics from standardization from our first two domains. We were able to reduce the number of distinct variable names in those two domains by 25% across the 84 studies we currently have in our warehouse. Also, now the percentage of variables in those two domains that are standard is greater than 67%. Once that second machine learning model is introduced, we expect both of those numbers to change. Next, I would like to talk about the SDTM process. This process takes amongst the most hours for any process in the CRO lifecycle. Standardizing the variables when they hit the warehouse, along with standardizing the spec sheet that the SAS code can utilize, makes the whole process much quicker. Ultimately, the EDC that was used for the study does not even matter. This is because the forms and the questions have been standardized and centralized in the warehouse. Our spec sheet determines the variable data type, such as result or finding in original units or completion status, and along with its test code and form code, provides an easy to edit spreadsheet for our SAS programmers. From there, they edit and validate as needed. Every study is different and unique, and even with the best standardization, it is expected that small edits will be needed. Regardless, this will reduce the amount of hours needed for SDTM by over half. Another complexity of the process is that each domain requires a different spec sheet. This makes sense, as variables important to the SDTM process within OE will not be identical to VS. In addition, events domains and supplemental variables need to be handled correctly. The most complex domain that we currently support is ophthalmic examinations. This domain often has over 15 forms per study. We are able to match these forms at an 85% rate, and the questions are being mapped at an 80% rate. So this means 20% are unmapped. However, unmapped variables often are supplemental variables and therefore are handled correctly. So we will never get to 0%, but we do expect a further reduction as standardization of the variables increase. So in order to get the most out of this process, that standardization needs to stay ahead of the SDTM domains that are being worked on. This is actually another example of the team deciding to take a step backwards in order to ensure that we're on the right path to proceed forward. Originally, a complex MaxGene algorithm was utilized to generate the spec sheet. While it was usable and the output was great, the code was complex and difficult to expand and maintain. A decision was made to further leverage our standardization of variables, which has led to much simpler code with the same great output. While this decision caused us to stop active development for about a month, I feel much better about the long-term success of this project. Another excellent process in which to leverage the combination of the data warehouse and the standardization of forms and questions is in the development of standard listings. There are a handful of reports that are useful for every study, and by ensuring that variables are consistent within the warehouse, a common report can be run for every study. This is a fantastic outcome, as it means right at the launch of a study, these listings can be accessed, as no unique code needs to be written for it. Visualization software, such as Power BI or Tableau, can be used to view these listings, in addition to allowing for each user to customize the listing if they desire. I mentioned earlier that I prefer small incremental releases. Augmenting standard listings into smart listings, these are listings in which a team member can add a note or a comment and it is retained and delivered in the future, is a great example of this. One of the more exciting possibilities is the ability to create a patient profiler for each study to monitor subjects either individually or in aggregate. This patient profiler is an example of our eventual increased focus on the external customer. While the primary customer is the company, as time goes on, projects like this can be tackled which have direct benefit to the external customer. One of our newest processes that is under development is that of serious adverse event PDF generation. When a serious adverse event has occurred within a study, filing a report to the FDA or other regulatory body within a short time frame is a requirement. Once again, leveraging the data warehouse and data standardization leads to a uniform process for most studies. An SAE hitting at the wrong time within a study can cause deliverables to slip, as priority must be given to this form. Our process is kicked off when an email is sent to a monitored account with information about the serious adverse event. That study is then refreshed in order to obtain the most recent data, which is needed to populate the form. Refreshing that study within the warehouse takes about 20 to 30 minutes. After it has been refreshed, the information has been collected and then populated on the form, and it is ready to review for within an hour, substantially reducing hours needed to gather data in order to complete this. All the study team needs to do is validate the data is correct and send it off to the regulatory body necessary. So this product is still under development, but it is something that we are very excited to offer in the future. The final project we are going to discuss is our newest, that of user acceptance testing automation. Before a study can go live, rigorous UAT needs to occur, another manual, time-intensive process. Of the 4 steps in the UAT process, we will be automating the final 2 as part of our initial release. That is, inputting values into the EDC and recording the responses. One complexity with this project is that while we have standardized and centralized the data warehouse, UAE testing needs to be done through the EDC, each of which has a different API or access point. This means that integrating each EDC requires incremental work. So while the data warehouse itself is of limited use in this application, data standardization is still a big benefit. As in other projects, a second release is already planned to automate the second step by populating different values to be tested for each question. This is where the data warehouse will shine because all of our data is standard. Those machine learning models can then identify similar studies to the target one and suggest the possible values to be input into the EDC for testing. Our hope today was to share some of our learnings in integrating a department dedicated to data insights and automation. The key points that we hope you take away today are, before jumping immediately into artificial intelligence, take the time to lay the proper groundwork. It will pay off both an increased accuracy of models later, as well as the speed in which they can be created and iterated upon. Furthermore, resources in this department can be utilized in other areas within the company to make tedious, difficult processes much smoother. The primary customer for this department is the company itself. The early benefit to external customers is through shorter timeframes, higher quality, and increased consistency. Over time, the focus of the department can shift to more external-facing applications. Quality data pipelines and warehousing will lead to effective artificial intelligence and machine learning investments. The combination of a data warehouse and data standardization is more powerful than the sum of their parts. Nearly all the custom tweaking of code and processes needed for each individual study is eliminated, leading to more consistent results faster. I appreciate your time today and wish you well if you choose to integrate a department of this type in the future. Thank you very much.